Okay, today in your lab, you guys did measurements. Okay, now when we're measuring things, we want to be as precise as possible. We want the measurement to be the same every time. Okay, that's precision, being the same every time. Accuracy is being right. So some things are going to be right, so hopefully our scales are right, but probably more importantly is that they're right every time. Okay, so that's the precision. Accuracy is being right, precision multiple times over. Now, when we measure things, we saw that some tools today were really good measures and some weren't so good measures. The problem comes when we have to measure with a not so good tool and then put it with a good tool as far as the measurements go. And that's where our measurements come from today when we talk about significant figures. Okay, in middle school and elementary school, when they told you, hey, we're going to round to the hundredths place, or we're going to round to the tenths place, wherever they told you to round to, they kind of gave you that information. Okay, significant figures is a really good measurement device or measurement tool to help us figure out, no, this is where we do our rounding. Okay, we're actually going to come up with why we are rounding to a particular number versus I'm the teacher, the facilitator, telling you this is where we're going to round. So I want you to be able to think that this is where we're rounding versus me telling you, hey, let's round to this particular number. Okay, so one of the things we did in class is we measured with a ruler. Okay, when you measured with the ruler, the sheet of paper, you probably came out with an answer like 0. Okay, because it's not going to measure that sheet of paper very well. You're going to look at it and say, yep, that's pretty close to 0. That's where it's at. Okay, a ruler is a poor measuring device for a sheet of paper. Okay, but it's a great measuring device for things that are much bigger. Okay, so when we're talking about like calipers, calipers are good measuring devices. You probably got an answer like 0.11, because a caliper will measure to the 100th of a centimeter. I'm going to label that. Okay, it measures a little bit further down. But then when we got the micrometer measures all the way down to a millimeter, okay, or the 100th of a millimeter. So this one is very, very accurate. It gets all the way down there. Okay, and that's a good thing. So if I were to compare these things, this 0.07 millimeters, if I put that into centimeters, I move the decimal over another 2 places. Oops. And that's where I'm at. Okay, a much, much, much better reading from the micrometer because it's a much better tool. So if I were to compare these things, if I were to have data from group 1, group 2, group 3, group 4, and I were to get an average out of these things, I would end up with data all over the place and I wouldn't know what to do with it. Okay, that's why we need to use significant figures. So let me show you really quick what a sig fig looks like. Okay, when we measure things, we can only go as far as our least accurate measurements. So if I am measuring with a ruler, okay, and it's got little tick marks in it. Now if it's a metric ruler, those tick marks are going to be every 1, 2, 3, 4. Usually the 5th one's a little bit bigger. Not all of them though. 6, 7, 8, 9. Okay, and then the 10 is really big. And it keeps on going on and on and on and on. Okay, I'm going to put a jagged line here saying that this ruler is moving on. Okay, so we can definitely measure, if this is 1 centimeter right here, we can definitely measure points on this line. Okay, we know how to count. So if I put a line right here, I can count over to that 1, 2, 3, 4. I know that this is at least 0.4 centimeters. Okay, that's the precision of my ruler. It goes to that. But I can tell with my eyes Okay, we're given eyes. We can see things. I can tell that this line is in between the 4 and the 5. Okay, so that's why you want to get close to your measurement. You want to see what's going on here. So I see that this thing is in between the 4 and in between the 5. So this is called my uncertain measurement. This is called my degree of uncertainty. You're probably going to want to write that down because you need that degree of uncertainty. So I can go to 1 degree of uncertainty beyond my last measurement. Okay, I have an absolute measure that this is a 4 and this is a 5. It's marked. Okay, in between it's not marked, but I can guess. I can kind of get an estimation of where it's at. And I'm going to estimate that this thing is right in the middle. They won't always be right in the middle, but this one I'm going to say is right in the middle. So it's 0.45 centimeters. Okay, when I look at this, now I can say that my answer for this particular device has 2 significant figures. This has 2, and I'm going to mark that as just SF. It has 2 significant figures. Okay, so if I'm doing a multiplication problem with anything dealing with this, whatever it is, my answer can't ever be greater than 2 significant figures, because this one would limit it if it's more than 2 significant figures. We'll see lots of those. Okay, so this has 2 sig figs. Now let's see another particular problem. Let's say that I got rid of all these tick marks in here. And let's say that my ruler now still measures to the 1 centimeter mark, but now there's nothing in between, and my mark is right. Well, let's put it in the same spot it was before. Okay, let's say it's right there. But can I now look at this and say that this is 0.45 centimeters? Okay, I can't take it down that far. I'm not that good at measuring exactly where it's at. If I were to look at this, I would say it's not quite to the halfway mark. So I would say it's probably about 4 or 0.4 centimeters. I can't take it any further because this is my degree of uncertainty right there. Okay, my measurement is from here to here. I have no tick marks in between. That's my degree of uncertainty. Okay, I have 1 degree of uncertainty. So that's 0.4 centimeters. So if I'm collecting data from the class and I want to find out what the average is in the class. Okay, so what we do when we average is we take everything together, we add it up and divide it by the number, right? Okay, so we're going to add it up, and I'll tell you how to add later. We don't do a lot of adding with sig figs, but we do some. By the way, how many sig figs does this have? It has 1. And we'll do the dot right, not left. We'll talk about that in class, though. It has 1 sig fig. Okay, so if I were to add them up, this has 0.85 centimeters. That's my calculator answer. That's what I would get. Okay, but this has nothing right there. There's nothing. Okay, I'm not going to make it a 0 because if it's 0, that meant that I took the time to actually measure it. I didn't take the time to measure it. I don't have a tool that measures to the 0. So I'm going to cross through that and say, no, there's nothing there. So that means I can't use this. And if I can't use this spot, what do you think I can do with the 5? I can't use it either. So instead of being 0.85, my new answer has to be 0.80 centimeters. Okay, kind of kills you right there. Okay, now is it really 0.80? Did I take the time to measure it? Okay, that's a big thing right there. Okay, whenever we write a number, that's saying we took the time to measure it. Can I use this 0 there? Once again, no, 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 no. So my answer really is 0.8 centimeters. Okay, so I had to actually drop it down, and now it's a 0.8. If I were to take this and now divide by my number of sig figs, I only have 1 significant figure. So that means my answer can only have 1 significant figure. So I'm going to take this and divide it by the number of people I have, which is 2. And that will give me an answer of 0.4. Now, 0.4 has how many significant digits? It has 1 figure that it actually counts. Only 1. Okay? That's all a significant figure tells you, is what counts. Okay? Significant means it's actually relative. It actually means something, and the figure is your number. So I have 0.4, and you're going to want to label it. Okay, So remember, when we're talking about significant figures, the reason we're using them is because our measurement tool. Okay, we will see lots of them. I want you to go ahead and write this down in your notes because we'll see it. You write down the phrase dot right, not left. So dot right, not left, that's a phrase that we will see a lot. I'm going to write it down because that's how often you're going to see it. Dot right, comma, not left. Okay, and that just talks about our decimal points. Some of you put decimal points just wherever you want. We're going to be really strict about where we have the decimal, why the purpose of the decimal, or what the purpose of the decimal is, why we use it, and when we shouldn't use it. Okay, that's good for today. Tomorrow we're going to pick up on the lab again. We'll talk more about that in class, but make sure you have that. Make sure you talk about uncertain phrases we're going to use in class. We're going to talk about degree of uncertainty. We're definitely going to talk about dot right, not left. All right, have a good evening. We'll see you.